NASA discovers that space lettuce is not a solution for feeding astronauts. Space farming success story: lettuce grows fine, but won't feed anyone. Greetings, fellow observers. Commander Zix here with breaking news from Earth, where humans apparently spent years growing lettuce on space stations only to discover it contains 30% less calcium than Earth lettuce. NASA-affiliated researchers analyzed crops from the International Space Station and China's Tiangong-2 and found microgravity fundamentally scrambles plant nutrition. Translation: the solution for feeding Mars crews is deficient in the exact nutrient astronauts desperately need while their bones deteriorate in weightlessness. You can't make this up. So here's what happened. Research led by B. Barbero Barcenita at Texas A&M University and published in MPJ Microgravity compared space-grown romaine to ground controls under identical lighting and timing. Results showed calcium and magnesium dropped 25 to 31%, while potassium often increased, and iron varied wildly. The study also flagged lower phenolics, antioxidant molecules helping plants handle stress, plus fewer carotenoids supporting vision and immunity. Meanwhile, astronauts already lose bone calcium in microgravity because cells sense little gravitational pull. So space lettuce delivers less calcium precisely when bodies need more. Simple nutritional crisis, perfectly predictable. Let me paint this picture for you, space observers. NASA is now testing Plant Habitat 07 to understand how water levels shape nutrient content and plant microbiomes. The team analyzed 163 calcium-related genes showing changes during flight, matching higher bone turnover markers. Emerging evidence also points to leaky gut syndrome, where astronauts develop more permeable intestinal walls, letting irritants into the blood. The NASA Twin study documented gut microbiome shifts that rebound after landing. Scientists emphasize that Mars missions cannot proceed safely without understanding how spaceflight affects both human bodies and accompanying microbes. But apparently, growing fresh food in orbit creates nutritional deficits, stacking onto existing health problems. The irony is absolutely stunning. But wait, it gets better. NASA is exploring biofortification, breeding plants carrying extra minerals. They are testing fermented foods like miso and yogurt that survived 30-day orbit experiments. Researchers suggest growing naturally flavonoid-rich herbs like parsley and garlic. So humans designed elaborate orbital greenhouses for fresh nutrition, discovered microgravity sabotages mineral uptake, and now must genetically engineer vegetables or ferment everything. Meanwhile, Mars crews will eat stored meals, degrading vitamins for months before reaching farms producing calcium-deficient salads. Apparently, sustainable space agriculture requires a complete nutritional redesign. Here's where it gets truly fascinating. Humans invented hydroponics, perfected controlled environment agriculture, launched crops to orbit, harvested edible leaves safely, and then realized weightlessness fundamentally breaks how roots move, water, and absorb material, and absorb minerals. Every solution creates new problems requiring bioengineering, fermentation monitoring, and treating food systems like medical equipment. Mars missions depend on astronauts eating lettuce with less calcium while their bones weaken from microgravity. This is Commander Zix reminding all of you that while Earth celebrates growing food in space, it simultaneously discovers orbital farming produces nutritionally compromised crops requiring technological intervention at every harvest. Apparently, gravity matters when you're making a salad on this planet.